we are actually going to monitor the electron flow in an oxidation reduction reaction. So, which element in a chemical reaction, a redox reaction, which element is being oxidized, which element is being reduced. So that's our topic for today. How do we figure that out? So, oxidation reduction reactions, and we are going to start with Leo the lion says grr. Okay, what the heck? What does that mean? L-E-O, lose electrons, oxidized. Lose electrons, oxidized. Leo. Gain electrons, reduced. Okay, and it seems silly, but I think you will find yourselves thinking that saying quite a bit. Leo the lion says grr. Leo, lose electrons oxidized, grr, gain electrons reduced. Alright, so let's look at a question here. Let's monitor some electrons. Okay, two. No, I don't want to do that. Determine, okay, the following equation. Describe the reaction between oxygen and lead 2 sulfide. Determine which elements. Determine which element is being oxidized and which is being reduced. And also identify identify the oxidizing and reducing agent. Okay, so the following equation, and I'm going to put it over on the other board. The following equation describes the reaction between oxygen and lead 2 sulfide. Determine which element is being oxidized and which is being reduced, and identify the oxidizing and the reducing agent. So here's our equation. We have got lead 2 sulfide and that is solid reacting with O2 to give us lead 2 oxide, that is also a solid, and sulfur dioxide gas. Okay. Let's balance the same here. We have got 2, 3, 2, 2. Okay. So 2 moles of lead 2 sulfide reacts with 3 moles of oxygen to produce 2 moles of lead 2 oxide and 2 moles of sulfur dioxide gas. Okay, so our job here is to figure out which element in this reaction is giving up its electrons and which element is receiving electrons. Okay, so oxidation reduction means that there is a transfer of electrons somewhere. So the first thing we have to do is we need to determine oxidation states for all of the elements. That's the first thing that we do. And so, okay, both of these things, right, this is an ionic compound. And so the oxidation states are going to be the same as their ionic charge. So sulfur is a -2 and lead is a +2. Okay, so the oxidation state of lead, +2, sulfide is -2. Okay, this is elemental oxygen. Elemental oxygen. So that means that it has no oxidation state. Its oxidation state is 0. Okay, and again, you guys, we've got an ionic compound, and so each of these monatomic elements, their oxidation number is going to be the same as their ionic charge. So oxygen's got a -2 and a +2. Okay, so now I've got oxygen as part of a compound. This is a covalent compound, so it's going to be a little bit trickier. We're not allowed to just assign its ionic charges to them. Okay, so we've got oxygen's got a -2 oxidation state. I know that whenever it's in a compound. And in this case, you guys, I have 2 at -2. So overall here, I've got a -4. So this is a neutral compound. So it's going to end up having to equal 0. So what number plus -4 is equal to 0? That number is going to be +4. So that means that my sulfur here has an oxidation state of +4. Okay, so +4 on the sulfur, -2 on the oxygen. So I've assigned oxidation states to everything. And so now what I need to do is I need to look and see what has changed. So lead started as +2, ends as +2. Sulfur starts as -2 and ends at +4. Okay, so something's happened with the sulfur, and oxygen begins with an oxidation state of 0 and ends up with an oxidation state of -2. All right, so lose electrons oxidized, gain electrons reduced. And so sulfur goes from a -2 to a positive 4. Now, in order for sulfur to have a negative 2 charge, it's got 2 extra electrons, okay? And in order for it to have a positive 4 oxidation state, right, this isn't an ion, people. This is a covalently bonded thing, and our oxidation states are simply describing for us where they're telling us where the electrons are most of the time, shared electrons. Okay, it hasn't really given up 4 electrons. It just isn't allowed to keep them very often in the sharing. Okay, so anyway, we've gone from negative 2 to positive 4. That means that in order for sulfur to have done that, it lost 6 electrons. To go from negative 2, where it's got 2 extra electrons, all the way down to positive 4, where it's given up 4, right? So 1, 2, 3, 4, 5, 6 electrons have been given up by sulfur. So lose electrons oxidized. So what is being oxidized? Sulfur is being oxidized. Okay, elements are oxidized or reduced. Okay, simply the element. It's the atom itself. All right, now, what is being reduced? Gain electrons reduced. Oxygen goes from a 0 to a negative 2. So in order for it to get a negative 2 oxidation state, and ionic charge in this case, it gains 2 electrons. 0 to negative 2 gains 2 electrons. And so it's oxygen, the element oxygen, that is being reduced. Okay, now the agents, the oxidizing and reducing agents. Okay, the oxidizing agent is the reactant that contains the element that has been reduced. All right, so the oxidizing agent is the reactant that contains the element that has been reduced. Okay, oxygen has been reduced. It's gained electrons. That means that it has oxidized. It is the oxidizing agent. It is what has oxidized the sulfur, taken the electrons from the sulfur. And so, now notice, you guys, it says the reactant, okay? It's going to be the whole thing. So agents are the whole compound. We don't just say a single element is an agent. We say whatever compound it's a part of, or whatever it appears as a reactant, that whole thing is the agent. And so, oxygen here as a reactant is actually O2. So we say O2 is the oxidizing agent. I wonder where that name came from. Being sarcastic, of course. It's from this. Okay, and because O2 is does this, takes electrons. So they phrased it after it. Okay, and is the reactant. That contains the element that's been oxidized. Okay, so what element has been oxidized? That's been sulfur. Okay, so we would say then that the reactant that it's part of is the lead 2 sulfide. So the lead 2 sulfide is the reducing agent.